Hello, hello, hello. Good morning, everyone. Good morning, as usual. First of all, tell me if everything is fine. Audio and video are all working properly. Great. How many people? Four people. Great. It's fine. So, last few weeks, I think 3 weeks are left for Nest, and in these 3 weeks, let us quickly get familiarized with what kind of questions Nest has been historically asking. Starting from 2018 to 24, every single PYQ will take a look at and analyze how the level of question is changing year by year, what kind of an approach Nest demands for solving at least the physics section. Let us see. Of course, we can't solve each and every question for each and every step. So you might have to fill in a few steps yourself, but nonetheless, every single concept, every single answer, we will see. Let's have the first one. We've been given a carom coin of radius 1.5 centimeter. So we can consider it to be a disc, a very, very thin disc whose radius is given to us. And we have its mass also. It is striking the board at 30 degrees with respect to the normal. So we can draw a diagram like this. If this is the side of the board, a normal drawn over here, the carom disc will strike at an angle of incidence of 30 degrees. Let's draw from the normal. It stays in contact for 10 power minus 3 seconds. So we have the value of delta t is equal to 10 power minus 3 seconds. And in this time, it suffers a collision, which is an inelastic collision, because it is emerging at some different angle. So it is emerging at an angle of 45 degrees. Let's draw this at 45 degrees with the normal. We have been given the initial speed u, which is 1 meter per second. U is equal to 1 meter per second. And final speed also we've been given v is equal to 0.7 meter per second. These are the total magnitudes of speed in the direction of motion. Keep this in mind. Now we need to find the average impulsive force. So delta F applied on the wall, of course, it will be applied normally. So this is the normal reaction force between the coin and the wall we need. Of course, the concept here is the stress on the word normal. Normal force only changes the momentum along this direction. So we can call this as the x direction. Initially, it had a value of some ux and uy, which we can now break down into their components. The horizontal component will be 30 cos 30. So we can break down u into its horizontal and vertical components as cos of 30 degrees I cap plus sine 30 degrees j cap. Since its magnitude is 1 itself, cos 30 and sine 30 will be the x and y components respectively. And since the final velocity makes an angle of 45 degrees, but its magnitude is 0.7, then the components of the final velocity will be 0.7 into cos 45 degrees, which is the same as 0.7 into sine 45 degrees. These will be the I cap and j cap components of the final vector. Now remember, momentum change only happens along the x direction, because that is the direction of the normal force, right? So if we take into account the change in momentum for here, delta v in the x direction, so vx minus ux we can write as 0.7 upon sine 45 is, sorry, cos 45 is root 2 minus of, it will actually be plus because the final velocity is in the negative direction. So if we take into account the vector forms, then 0.7 by root 2 plus cos 30 degrees, which is basically half, is what we get as the change in momentum. This will be the value of change in momentum. And if we simply divide it by delta t, we will get the value of force very, very quickly. 0.7 upon 0.2 is 1.414. 1.414, which is a little greater than 1.4. So this value will be a little greater than 1. It will be a little bit greater than 1. If we divide by delta t is 10 power minus 3, then we should get something a little larger than 10 power minus, 10 power 3. Right? Final values you can calculate. You have a calculator. 0.7 by root 2 plus, cos 30 is root 3 by 2. Root 3 by 2 you will get as 1.3. Approximately 1.3 we get the value of the change in momentum. And dividing it by 10 power minus 3, get 1.3 into 10 power minus 3. And its mass we have been given to be 5. So 1.3 into 5 will be the final answer. F is equal to m into delta V upon delta T. So 5 grams, which is 5 into 10 power minus 3 into 1.3 is the change in velocity into 10 power 3 will get cancelled with 10 power minus 3, and approximately the force is coming to be 7 newtons. Does 7 match any option? Yes, option C is exactly matching. This question was not very complicated. It was very, very straightforward. All you had to do was calculate the change in momentum in the normal direction and divide it by the time duration of collision, and you get instantly the change in force also. The force normally applied by the wall, you get like this. Again, very, very simple definitions, just the calculations were a little bit lengthy. You have to first calculate the x components during collision, subtract them, and then multiply by mass also. If you can do these calculations very, very quickly, then yes, you can solve this easily. Doing this PYQ will be enough? No, doing this PYQ will not be enough. Just coming for these sessions is not enough. Looking at how the solutions are approached is not enough. You will have to solve PYQs yourself. You will have to solve mock tests yourself without looking, without checking anything else. That will be enough. These discussions are just to help you approach questions, but as long as you don't approach questions yourself in timed mock tests, nothing can ever be enough. We can give you 100 discussions, but just you solving 10 mock tests by yourself without looking anywhere else is more than enough. In this question, we have been given a disk which is rolling on a horizontal surface. Center mass speed is v naught given to us, and a point at a distance of phi r by 2 is also given to us. Now we need to select the correct option about the angular momentum about that point. The angular momentum about that point we need to consider. We know that there will be angular momentum due to the motion of center of mass with respect to the point P. The angular momentum around P will be equal to mass of the disk into velocity of center of mass of the disk into the distance between the center of mass and the point P. Right? The distance between center of mass and point P is basically 5r by 2 minus of r. So thrice into r by 2 is the angular momentum about the point P. Right? When it follows a rolling without slipping condition, only its center of mass will move with a constant speed. Hence, we can write this as the angular momentum. But until and unless it attains this constant speed, what will be happening? It will be rotating faster than it would be moving. That means the center of mass will not attain a velocity v naught until it starts rolling without slipping. Right? Is everyone able to see? Its angular momentum will keep decreasing because of its fast rotation, slowing down, and hence the final value will be this. Again, all you have to do over here is check each and every option whether it makes sense or not. We start rotation of the disk first, hence it will slowly tone down the rotation in order to attain a pure rolling without slipping condition. Note down, quickly note it down. Again, if you know the fact that angular momentum of a moving body along some fixed point is mvr, r taking perpendicular distance, then you will easily be able to solve this also. Next question, let's take a look. In this question, we have a PT diagram. Sorry, we have a PT diagram, and all we've been given is that there is an ideal gas over here. So no degrees of freedom nonsense, just 3 by 2 kT we know can represent the energy. And also we can use ideal gas equation for this gas. We have been asked to calculate the corresponding density versus temperature plot. Density versus temperature we have to plot. First of all, how do we get density versus temperature? We need to relate those two quantities first. It's an ideal gas. For an ideal gas, we know that PV is equal to nRT. The ideal gas equation holds exactly, right? The number of moles we can write as the total mass of the gas. The total mass in whatever container we have kept, we can write as m, and the molar mass we can represent as usual with capital M. In this case, we can represent the number of moles as total mass upon molar mass. So PV we can rewrite as total mass over the molar mass into RT. Ideal gas equation takes this form. Now, why is it important? Because the density of the gas will be equal to total mass upon volume. The density is given by total mass of the gas upon the volume of the container in which it is kept. So in order to get that term on one side, we can rewrite this as P into M, taking M on the LHS, should be equal to mass upon velocity, which is, sorry, volume, which is just the density, into RT, which is simply rho into R into T. And since we need to compare rho, that is density, with temperature, we can rewrite this as rho is equal to Pm by RT. If you know this formula, it's a standard result. Rho is equal to Pm by RT for a standard gas. If you memorize this, then in the final exam, this might come very, very useful if a question has been asked for the density. Again, it doesn't take a lot of effort to memorize these results once you derive them yourselves. That's why I showed you this derivation very, very quickly. Just derive it yourself once, you will never forget this simple relation. Rho is equal to Pm by RT. That is, it is inversely proportional to temperature. For an ideal gas, it will be inversely proportional to temperature. Now let's take a look at the PT diagram given to us. Sorry, proportional to pressure upon temperature, right? And according to this PT diagram, process 1 to 2, the temperature is constant and pressure is increasing. Temperature is constant and pressure is linearly increasing. So for 1 to 2, the rho should also be linearly increasing. For 1 to 2, rho should also be linearly increasing. So option D we can rule out very, very quickly, because rho is not at all changing for 1 and 2. Let's take a look at process 2 to 3. In process 2 to 3, P and T are both linearly increasing. P goes from 3P to 6P and T goes from T to 2T. The slope is 3 by 2. Slope is 3 by 2. So rho should once again linearly increase with 3 by 2, which corresponds to option C. We can see, sorry, 3 by 2 it is decreasing. Yes, 3 by 2 it will decrease. Similarly, 3 to 4 we can see similar process, P is constant, and 4 to 1 is also a similar process, P and T both change linearly. So option C matches in this case. Note it down quickly, note it down. You can change from one type of diagram to another just by writing ideal gas equation and comparing how the quantities are changing. Again, if you know the results, these types of questions are very, very quick for you. In this question, we have a cylinder, metallic cylinder with height h and inner outer radii given to us as R1 and R2. Now, if we pour water into it and we heat it with a constant power source means the heat supplied increases linearly with time. One of the ends is maintained at T1, at which we are heating it. In steady state, we have been given the temperature of inner outer surfaces T1 and T2. That means the inner surface attains the same temperature as the heat source, and the outer surface has some temperature T2 because some heat current is flowing. Now we need the temperature difference between T1 and T2. Again, if you know just how to tackle these questions using the tools given to us, it should not be a very big deal. We know how to tackle the heat conduction in a thin rod. Thin rod case we know, but we don't know the case of a cylinder. For non-standard cases, you can consider it to be a standard case, right? If we take the top view of this cylinder, because we know that heat will travel radially outwards in this shell. Heat travels radially outwards. We know this. So if we consider a cylindrical element at constant radius from center, across this element we can consider the temperature difference to be dT, right? And its thickness to be some dr. Dr is its thickness at a distance of r from the center is the shell, right? How can we write the thermal resistance of this? Thermal resistance we can write by dr as resistivity into the length across which the heat travels. The heat is traveling across a thickness dx. So the length element will be the thickness dx upon the surface area through which heat travels. Heat travels to the cylindrical surface area or the curved surface area of this shell, and hence the surface area will simply be 2 pi r into h. 2 pi r into height of the cylinder will be the curved surface area. And we can replace a resistivity with 1 upon conductivity. Expression will be 1 upon dx by 2 pi k into RH. This will be the thermal resistance. And since we are connecting many of these layers from a radius of R1 to radius of R2, this radius is R1, this radius is R2, the total thermal resistance will simply be the integral of this. 2 pi and kh will come out, 1 upon 2 pi kh into dr over r, starting from inner radius to outer radius, because we know temperature between inner and outer radius also, right? This will come in a logarithmic form, that is 1 upon 2 pi kh, or we can write log of r1 over r2 upon 2 pi kh. This is the thermal resistance across inner and outer radius, right? So the temperature difference delta T will simply be proportional to this thermal resistance, proportional to R into the heat current Q dot, which we know is constant. Right, note this one quickly. I'll be back in just a minute. I think process हो गया अब तक. Noted. These type of questions are also not a very big deal. All you have to remember is that of the direction in which heat travels, we will consider that as an effective rod system. Length of the rod will be the distance across which the heat travels, and area of the rod's cross section area will be the surface area through which heat travels. If you can imagine the transfer of heat across any shell, then these questions are also very, very doable. Let's look at the next question. In this question, yeah, we have a source which is emitting a basic frequency of f. If it moves towards a wall with some speed vb, then a stationary observer behind the source will hear some beat frequency. What is that? We need to calculate. Again, a system like this, yes, if we consider this to be a wall which reflects sound, this is a source and moving away from a detector, it towards a wall with some velocity vb, let's say. The frequency that the detector will hear reflected by the wall will basically be the frequency that the wall hears. But you can solve this much easier by considering an image source. This image source S dash will be moving towards the wall with some speed vb. If you can see the mirror image, then the sound emitted by the mirror image will be heard by the detector. You can assume this also. So detector will hear one frequency f1 from this source and one frequency f2 from the image source also, and their difference in frequencies will be the beat frequency observed. Again, for all problems involving reflection of sound, simply draw a image source considering the wall to be a mirror, and the sound emitted by image source will be the sound heard by the detector also. So applying Doppler effect for f1, we get the value of f1 as f. And again, very, very simple trick. If a source is increasing separation, then its velocity will try to decrease the frequency. Source always goes in the denominator. Source is traveling away from the detector. In the first case, separation increases, frequency should decrease. So v plus source speed vb will be the frequency heard by the detector in the first reflection. This is for the first reflection. And for the second reflection, so second source, where it is moving towards the observer with speed v, the frequency f2 will simply be f into the speed of detector, so will increase the frequency v minus vb upon v. Taking the difference between these two frequencies, we get the exact value of beat frequency. Beat frequency will be v upon v minus b, sorry, vb minus v upon v plus vb. If you cross multiply, you get v square plus vb minus of v square plus vb. So v square and v square gets cancelled and vb gets added up. Sorry, there is an f also. So twice of v into vbf upon a plus b, a minus b, we can write it as v square minus vb the whole square. Whichever option matches has to be the correct option. Yes, option C we can see is clearly matching. So for all such questions, don't fall into the trap of first looking at what the frequency heard by the wall will be, then frequency of the reflected sound will further get Dopplered by the relative motion. Simply draw the image source and calculate the frequency of that sound. Let's look at the next question now. In this question, we have a lens which has focal length f such that the distance between object and whatever screen it is projecting its image on is 18. Now we need the image of the object to be formed exactly on the screen, a very, very sharp image. Right? Let us draw the ray diagram first. If this is a lens, this is a screen, and this is an object. The object distance u and the image distance v, we know the sum of u plus v to be 18. Right? Sum of u plus v is 18. And since the image is formed on the screen, we know it has to be a real image. It's a real image, and since the lens is between them, the image also has to be inverted. Image has to be inverted, and it has to be a real image also. The focal length is given to be 4. We can use the lens formula over here. 1 upon 4 should be equal to 1 upon v minus of 1 upon u. If this is the origin, and as usual, positive x-axis is towards the left, then we can write u as 18 minus v. Right? The value of u is simply 18 minus v. And since it's in the negative direction, we can write it in terms of v. Because that is all we need. All we need is the value of v. And then the ratio v by u, you can also calculate to get the magnification. So we can write minus of 1 upon 18 minus of v. We can write this as, and since a negative sign, we can write as v minus 18 also. It's clear or not? Tell me quickly tell me. That's it. We can get the value of v from here. V minus 18 minus of v plus 18. So this will be 18 minus v. 18 minus v. We can get like this. And from here, I think v should be equal to 12 upon, yeah, minus v by u is what we require. Magnification is equal to minus v by u, and again minus of v upon 18 minus v. We can write here a plus sign. Right? We can calculate v from the above formula and substitute over here to get the answer. Note it down. Quickly note it down. We'll get v is equal to 12 centimeter. Yes, we get v as 12 centimeter if we calculate this. It's equal to 12 centimeter. And if we substitute v is equal to 12 over here, minus of 12 upon 18 minus 12, it is 12 by 6, so it will be minus of 2. So negative magnification means, yes, for sure, the image will be inverted. Image will be inverted, it will be real, and the magnification will be twice. Option B exactly matches from here. All you have to do over here is use the lens formula and the information given to you that distance between object and screen is 18 centimeter. Rest everything just by substituting values follows very, very quickly. Let's take a look at the next question. Similarly, this question, we have a simple harmonic motion, and if we capture the particle at very, very large number of times, then plotting a histogram basically tells us how much time a particle spends at one particular distance. So if this is x-axis, starting from the mean position to some amplitude a and negative amplitude minus of a, particle is performing SHM. Right? We know at x equal to 0, the velocity is maximum, and at x equal to the extremum, the velocity is 0. Since velocity is 0, it will spend maximum time in this region, and it will spend minimum time around the center, because since its speed is maximum at the center, it will get away from that region very, very quickly. And since the velocity attains zero value, the speed will be very, very slow around the maxima, and it will spend more time. So it will have a minima around the mean position. That is all that is asked. How much time does the particle spend, so that we will get many more photos of the particle at that position. Hence it will have a maxima around the extreme value and minima around the central value or the mean position. Again, if you can imagine or simply know the theory of SHM, how the particle behaves, how much time a particle spends in one particular region, this is a very, very simple question. But it is conceptual. You need to think quickly. You need to be able to recollect all of these properties of SHM very, very quickly. Only then will you be able to do this question quickly and spend more time on the more tougher questions, which we will see. There are tough questions in this paper also. Let's look at the next question. Oh, this is the next question. No? This was the next question, right? So we have been given four wires. Q wire comes out of the plane of paper. R wire goes into the plane of paper. T and S also have corresponding behavior, right? We have been given that all of them carry the same current I. Current is the same, but the direction of current is different for all of them, right? We need to calculate the magnitude of magnetic field at the point O. How much magnetic field will be exerted at point O, we need to calculate. Again, we need to use a right hand thumb rule for this. From Q, we will get a magnetic field pointing towards R. Due to Q, we have one magnetic field. And similarly, due to R, also we have a magnetic field, but along this direction. Simple right hand thumb rule, R goes inside, so magnetic field will be tangential at this point. Again, due to P, the magnetic field will also be tangential around this point. Let me label these magnetic fields. Magnetic field due to Q, magnetic field due to R, this is magnetic field due to P, and due to S, again the magnetic field will be tangential parallel to R, magnetic field due to S. So the resultant of all of this, you will basically add the vertical components and the horizontal components exactly get cancelled out. In very, very simple, just use Barrett-Schwarz law over here and you will exactly get the value of magnetic field. It's clear or not? Tell me quickly. Quickly tell me, is this clear? Since the side length is given to us as A, the distance between Q and P will simply be A by root 2. The diagonal of a square we know is A by root 2. Right? So the total magnetic field will be mu naught into current is capital I, let's write capital I, upon 2 pi into A by root 2. This is one individual value of magnetic field. And if we take the cos component, cos 45 degrees, we are basically adding all of these such magnetic fields together. Is it clear or not? Tell me quickly, tell me if this is clear or not. 2 and root 2 will get cancelled and we are multiplying it 4 times. Right? So 2 and 2 will get cancelled, root 2 will go upwards, and cos 45 degrees also 1 upon root 2. So the net value of magnetic field will be 2 into mu naught into I upon pi A. This is the net value of magnetic field. Again, similar 4 vectors, we are taking the vertical component and adding up. Simple Barrett-Schwarz law as well as right hand thumb rule will give you the value of magnetic field. Let's take a look at the next question. Then in this question, we have again two semi-infinite plates lying parallel to xy plane. So let's draw the xy plane in 3 dimensions like this, and we have two parallel plates in this way, right? We need to find the direction of electric field at point 0, 0, 2D. So in the z direction at 2D, we need to calculate if this is the origin and both the plates are at perpendicular distances d. So at some point 2D in the z axis, we need to calculate the direction of electric field. These are infinite plates. These are very, very infinite plates. But these are semi-infinite. Semi-infinite plate start at one point and only stretch in one direction, x equal to 0 to x equal to infinity. So in x direction, they are semi-infinite. In y direction, they are infinite. How will the electric field be? Electric field will have x and z components. It will not have any y components because y components will exactly balance out. Y components balance out because y stretches from minus infinity to infinity. But since x only goes from 0 to infinity, the magnetic field will be away from x for the positively charged plate and towards x for the negatively charged plate. Right? If this carries a density of sigma and this carries a density of negative sigma, then electric field due to positive sigma should be away from the x-axis and away from the z-axis also. It should be a repulsive electric field. So the direction will be equal to I cap plus k cap direction. I cap plus k cap will be the direction of electric field due to the semi-infinite plate plus sigma. And similarly, due to minus sigma, the electric field will be in the direction of I cap will still be towards x and j cap will be negative because it is attractive towards the negative direction. So I cap minus of k cap will be the electric field direction due to this negatively charged plate. If we add these two, k cap and k cap will get cancelled. Adding these, we will get twice of I cap as the direction of electric field. Again, it will be along the x direction. It's a very, very important result. The direction in which the plates are semi-infinite will be the direction of the resultant electric field also. Note it down quickly, note it down. Next question. In this one, we have a solenoid such that a wire having diameter d is wound around a cylinder whose height is fixed and radius is less than its height, but it is much more than the diameter of the wire also. The radius is greater than the height. So the cylinder is a very, very stout cylinder, you can say. The cylinder is stout, but the thickness of the wire is very, very thin as compared to the radius of cylinder itself. And yeah, considering an ideal solenoid, winding must be tight. Basically, it tells that there's an ideal solenoid. We need to just check all of these options, the number of turns per unit length, how much it would be, everything we need to check. Let us see. The height is given to us as h, the radius is r, and if we look at the wire, this is the wire, the diameter is given to us as d, right? Magnetic field will still be the same. The magnetic field expression will not change, but there will now be a sine theta component, right? Magnetic field will now be proportional to mu naught into number of turns into the current. It will be proportional to mu naught Ni, but there will also be some end corrections to this. Anyway, we are not interested in that. We are interested in the number of turns per unit length, which is option A. How can we calculate the number of turns per unit length? We know the width of each turn is the diameter. Width of each turn is the diameter. So we can roughly equate the height of the cylinder to be equal to number of turns into the diameter of each. Right? Number of turns into diameter we can represent. So number of turns comes out to be proportional to 1 upon diameter, since the height is fixed. So option A is correct, but there can be more than one correct options also. Let's check other options. Resistance of the wire is proportional to D. We know this is not true. We know this is not true because resistance, no matter what kind of a wire it is always equal to rho into length of wire upon the surface area of the wire, which is equal to rho into L upon pi r square for cylindrical wires. R is basically half of diameter given to us. So resistance is proportional to 1 upon diameter square, not 1 upon diameter. Option B is not right. Option C says that current to be passed through wire is proportional to 1 upon D, such that a magnetic field B is produced. We know the total number of turns per unit length should be equal to, should be proportional to 1 upon D. So current should technically be proportional to D, not proportional to 1 upon D. Option C is also wrong. Heat produced is proportional to 1 upon D. Let us see. Magnetic field is constant, then current should be proportional to 1 upon N, which is proportional to D. And if we consider the heat produced, which is basically proportional to I square into the resistance is proportional to 1 upon D square, and I square is proportional to D square again. I square is proportional to D square, and resistance is proportional to rho into L by A. So again 1 upon D square. So heat along it should be constant. So option D is also not right. Option D says it should be proportional to 1 upon D. Is it clear? All you have to check is proportionality from here, and each and every option you will see option A is coming right. Let's look at the next question. In this question, we have a tuning fork such that its length is L and one of the ends is closed. The waveform is given to us. This is half of the wavelength, and the total length is 3 by 4 times lambda. 3/4 of lambda is the total length of the tube. So L is coming out to be 3 lambda by 4, and wavelength will be equal to 4 into L by 3. 4L by 3 comes out the wavelength. So option A is wrong, we can clearly see. Option B says that P3 is a displacement node at P3, right? P3 is basically a pressure node given to us. P3 is a pressure node. Low pressure point will have a high displacement, right? The variation of pressure is given to us. So C is a pressure node and pressure is 0 at P3, and P2 is a pressure anti-node. Displacement node will be at P2 now. Right, so option B and C both are wrong. Option D is correct in this case, because we can equate lambda to be equal to speed of sound upon frequency and get the velocity of sound in air also. Note it down, quickly note it down. In the next question, we have two solid blocks at temperatures T1 and T2. T1 is colder and T2 is hotter given to us. If they are placed in contact, after a long time, they will attain thermal equilibrium. We can't comment on thermodynamic equilibrium, but they will surely attain thermal equilibrium. Right, let's check the correct options now. Spontaneous regaining of initial temperatures by two blocks does not violate the first law of thermodynamics. What is the first law of thermodynamics? That the heat transferred from the hot object to the cold object should be equal to the heat received by the cold object, right? So if we were to reverse the process, the cold object would supply heat to the hot object, but as long as heat supplied is equal to heat accepted, heat supplied, as long as it is equal to the heat received without loss of energy, of course the first law is not violated. So we can technically reverse the process without violating the first law. However, it does not happen because we now know that the second law gets violated. The option B is basically the statement of the first law. The amount of energy released by hot block should be equal to amount absorbed by the cold block. It is basically a statement of first law. So B is also correct over here. Option C says that entropy is maximum when thermal equilibrium is attained. When thermal equilibrium is attained, entropy of the system cannot increase beyond that. Why? Because if it increases beyond that state, then that means that the system is going into a more stable state. Which is the most stable state that the system can be? In equilibrium. Equilibrium is a stable state, and if there was any more stable state than equilibrium, then entropy would increase so that system attains that state. Keep in mind, most stable state entropy has to be positive. That is basically a statement of the second law of thermodynamics. So options A, B and C are correct. Note down quickly, again very conceptual questions, but the trick here is that you will keep questioning your own understanding of laws of thermodynamics when you look at the different options. You will think, oh no, but if this spontaneous process is not possible, maybe it violates the first law, that is why it's not possible. You might fall down a well, I would say, of wrong thinking, of misapplying concepts. Definition should be very clear. What is the first law? What is the second law? At least these two statements should be clear to you. First law talks about the transfer of heat. Second law talks about the entropy change. If you know these concepts, then you can easily remember and apply in questions also. Let's take a look at the next one. In this question, we have again a simple harmonic motion. Time period and amplitude is given to us. Maximum speed is also given to us. And they said that the particle is at mean position at t equal to 0. At displacement y, the velocity is v. Then for some time t, which is less than 1/4 of the total time period, we need to check the correct answers. If the velocity v is at half the maximum velocity, then we need to calculate the value of y. SHM basic theory, you should know that velocity at any displacement y should be equal to omega into under root a square minus y square. Very standard result. Everyone should know this result. It is basically the kinematics for a simple harmonic motion. And v maximum in this case is equal to omega into the amplitude itself, a, and omega we know is 2 pi by time period, or t is equal to 2 pi by omega. We can calculate from here. So if the total velocity should be equal to half of the maximum velocity, which is basically a into omega upon 2, then equating it to omega into under root a square minus y square, omega gets cancelled. Squaring both sides, we get a square by 4 should be equal to a square minus y. a square minus y is the value of the displacement where the maximum speed is half, right? So from here we will get the value of y will obviously be greater than a by 2, because a square minus a square by 4, y is equal to root 3 by 2 a square, which is greater than 3 by 2. So option A is correct in this case. Option A is correct here, right? Y is clearly greater than a by 2. And at y is equal to a by 2, we have to check whether kinetic and potential energies are equal. Kinetic energy we can calculate half mv square as half into m into omega square. A square minus y square is the kinetic energy. This should be equal to half into m omega square into x square is the potential energy. Sorry, y square, not x square. Displacement is given to be y. This is the condition when kinetic and potential energy will be equal. Half m omega square get cancelled on both sides, and we get the value of y square to be a square upon 2, cos 2y square will be equal to a square, and y is equal to a by root 2. Y is coming as a by root 2. Option says a by 2. So option B will not be correct. Let us check option C now. Magnitude of acceleration we need. Now, for simple harmonic motion, you should know that acceleration is equal to minus of omega square into y for any value of y. This is the basic definition of simple harmonic motion. Acceleration should be equal to minus of omega square into y. So when acceleration is a by 2, that basically means that, let's compare, acceleration is equal to, acceleration at y is equal to a by 2 will be minus of omega square into a upon 2, and acceleration at a by 4 we can calculate a2 as minus omega square into a by 4. We can clearly see a1 is equal to twice a2. So option C is also correct. Option D says that at time is equal to t by 8, 1/8 of time period, we need to calculate the value of y. Again, we know how y goes with time over here, right? Y is equal to a sine of omega t. At time t equal to pi by 8, it will be a sine omega is 2 pi by time period into t by 8 will be pi by 4. A sine pi by 4 is a over root 2, which is greater than a by root 2 also. So option D is also correct from here. You just have to check different options. Since all 5 are different, you have to check each and every one of them and tick the correct statements. Questions are straightforward, just there are too many things to do. You have to check four things at a time. So these questions are time consuming, but these questions are very easy. This is why I keep telling you, solve questions yourself without looking anywhere else. You need to get into the habit of writing all of these calculations very quickly as I am writing on the board. You should write on your rough sheet kept in front of you. Only if you can improve your speed in doing this calculation quickly, you will be able to solve many more questions in the final exam. In this question, we have a force given by alpha into beta vector cross some p vector. P is the momentum and beta is some random vector. Alpha is a constant given to us. It's a scalar constant. Again, we need to check 4 different options for 4 different magnitudes. Now, the dimension of alpha beta first we know dimension of force is mass into length time raised to minus 2. This is the dimensional formula of force, m into a, mass into acceleration, and it should be equal to the dimensions of alpha into dimensions of beta, and dimensions of momentum is basically mass into velocity. M and L will get cancelled exactly with M and L. T inverse will get cancelled with T raised to minus 2 to get T raised to minus 1. So the dimensions of alpha and beta come out to be, sorry, there's no mass, just time raised to minus 1. Option A is incorrect from here. Now we need the component of P along beta, whether it is a constant or not. How will we get component of P along beta? We know that the force is rate of change of momentum. Rate of change of momentum is force, right? So if the cross product of beta cross P is in the same direction of rate of change of P, this is only possible if the component of P along B is constant. If the value of the cross product does not change, at least the projection of it does not change, only then will the cross product be parallel to the rate of change of a vector. If both of them are constant, this is the only case possible. So option B is correct over here. The magnitude of P may or may not be constant. We don't have enough information to check if the magnitude of P is constant. Have we been given anything? No, we haven't been given anything. Yes, we have not been given anything. P will be perpendicular to dp by dt. Yes, because dp by dt is the resultant of some cross product B and P. Cross product of B and P is the resultant dp by dt. So P has to be perpendicular to dp by dt. Option C is correct over here. Options B and C are correct. We can see from this question. Simple, right? All you have to do is check options, literally nothing else. If you can check options quickly, then you can also solve very, very quickly. Let's look at the next question now. Oh, we are done. 15 questions. Yes. Next, we used to have 15 questions at that time. Yes. I thought, as usual, 20 questions will be there, and I was fully prepared to take this more. So, as you can see, in the year 2018, NEST was not really going heavy into the conceptual questions. Conceptual questions was easy. They were there. NEST used to ask very deep concepts, but the questions themselves were very, very easy. They were lengthy because you have to do four calculations in one questions. That part has remained. Every question will be as lengthy as doing 4 calculations even now. So the thing you can take away the most from this is how to approach these conceptual questions quickly. The only way is by practice. If you can memorize results, then these will be very, very fast. Else you have to practice thinking as much as possible, practice writing as much as possible. Only then will you be able to solve these in given time. Fine. This was 2018 PYQ. The next time we will take 2019 PYQ. Let's meet next class at our usual time then.